They are scaled-down versions of full-size humans, with legs, arms, and heads in proportion to their bodies. His normally functioning internal organs are small-scale, around 3 feet tall. That's about half the height of a typical adult male. But there have been full-grown primordial dwarfs even shorter. However, in primordial dwarfs, the ball of the thigh bone is not a perfectly engineered sphere, so the ball and socket don't fit together perfectly. Thigh bone, the ball and shaft are angled so that when the leg is in a standing position, it's perfectly straight. But in primordials, this angle is skewed, causing the thigh bone to bend inward when they are standing. Somewhere between the 12th and 14th week of gestation, ultrasound can detect that a primordial dwarf is smaller than an ordinary fetus. At birth, the average primordial weighs about 2.5 pounds. Small compared to the average boy at 3'2" and 32 pounds. He didn't reach 3 feet tall until age 11. Danny finished growing when he was about 12, common for kids with his syndrome. Today, at 40 pounds, he's entering manhood with just 1/4 the mass of the average man. And since he is proportional to a full-sized man, his internal organs only need to be 1/4 size as well. The heart of a typical 18-year-old pumps 6 quarts of blood per minute. Danny's pumps just 1.5 quarts, but his miniature heart, lungs, and liver, also 1/4 size, compare in function to an ordinary brain. These cells, called neurons, connect with each other in a vast network. As a child learns more, the number of neural connections rises and causes the brain to expand. With normally developing brains, soft membrane-covered gaps between the bones of the skull allow it to enlarge as the brain grows, curbing skull growth at an early age, which slams the brakes on brain growth.
I get around by scooter. It helps to make sure that the kids don't hit me, like run me over.
Prominent noses with wide bridges, ears that often lack lobes, thin, wispy hair, tiny teeth. But scientists have no idea why the dwarf's genetic mutation is expressed in these peculiar ways. Primordial dwarfs' eyes appear unusually large. The eyelid opening is often so small that only the iris is visible. Many primordials start wearing glasses at an early age, due to the way their eyes grow. The human eye is designed so that when rays of light pass through the lens, they are perfectly focused on the retina, the ultra-thin screen of light-sensitive cells at the back of the eye. The focus is sharp because the distance between the lens and the screen is exactly right. But in primordial dwarfs, the eyeball often does not grow long enough. The light rays focus behind the screen rather than directly on it, so the visual image is blurry, much like an average person who is farsighted. Another noticeable trait of primordials is their voice.
They have very high-pitched, sort of squeaky, high-pitched voices, and you have to pay close attention to understand them.
The sounds of the human voice are generated when exhaled air flows between the vocal cords and causes them to vibrate. In primordial dwarfs, the vocal cords are much smaller, so they vibrate faster, creating a higher-pitched sound. Scientists understand the mechanics of how some primordial features work, but they don't know how the condition is caused in the first place. All they know is that primordial dwarfism is touched off by an extremely rare mutation in a still undiscovered gene. The syndrome is so rare it's hard to get a handle on. In the US, the odds of parents having a primordial dwarf are about 1 in 3 million. The chances are so slim because 2 copies of the mystery gene are needed, 1 from each parent.
Make sure the tape is in the right spot.
It wasn't until Danny was 7 that his mom and dad learned they both carried the mutant gene. and that each had given a copy to Danny. It could be they are distant blood relatives, linked by a common ancestor. And no matter how far back that ancestor lived, if he or she had the mystery gene, it could have been passed down through generations to his mom and dad. The odds that these two distant relatives would meet, fall in love, and have a baby who got 2 copies of the gene are extremely remote, which might explain why it always takes parents by surprise.
We never had instances of it in either one of our families.
Danny's parents had a 1 in 4 chance of having a child who did not inherit this primordial gene. They had a 1 in 2 chance that their baby would inherit just a single copy. In this case, the child becomes a carrier of the gene, but is not affected by it, just like his parents. They also had a 1 in 4 chance of having a child like Danny, who inherited 2 copies of this mystery gene. But how does the genetic mutation actually create primordial dwarfs? According to one theory, when someone inherits a pair of the mutant genes, they end up with a defect in their collagen, the most common protein in the body. This defect causes the collagen to grow in a way that blocks bone growth, causing dwarfism.
Collagen is one of the proteins in the body that is used to build structure.
As seen in these electron microscope images, collagen consists of sturdy white fibers found throughout the body. These fibers literally hold us together, reinforcing our skin, bones, tendons, blood vessels, and other tissues. To learn about the effects of faulty collagen, scientists have studied dwarf mice. In healthy mice, as in humans, collagen fibers run parallel to the bone shaft, giving it extra support and structure. But in dwarf mice, collagen runs crosswise, against the shaft, which prevents the bones from growing lengthwise. Scientists don't know if this same process could be stunting the growth of human dwarfs. But primordial dwarfs do seem to show other possible signs of having flawed collagen. Their ligaments don't work the way they should. Ligaments are mainly bundles of collagen fiber that connect muscles to bone and hold joints in place. These fibers are extremely stretchy in primordials, so that their joints are often loose. Another possible sign is that some of them have dangerously stretchy blood vessels in their brains. Usually, collagen forms a sturdy web inside vessel walls so that they can withstand the pressure of blood pumping through them. But this reinforcement is not strong enough in some primordials. The blood vessel develops weak spots called aneurysms where the vessel walls balloon out. These formations can burst, causing massive hemorrhages, a chief cause of death in primordials.
One of the routine things we use in the primordial dwarfs is monitoring with MRI, because if these aneurysmal swellings are found, they can now be treated.
Surgery can treat some aneurysms. Fortunately, Danny doesn't have any. And whether or not his tiny size is due to flawed collagen can't be nailed down until science uncovers the primordial gene. But some dwarfs aren't waiting for future scientific discoveries and are